Talking about decimals. Now, decimals are just another way of expressing a fraction of a whole or a part of a whole. If we have an example of a decimal such as 0.325. Now, one of the things you should know is that the first place after the decimal point in a decimal number is designated the tens place. The second place after the decimal is designated the hundredths place. And the third place after the decimal is designated the thousandths place. These are the values placed on each of those places after the decimal points. We can have more numbers, but let's stop here for now. And so if we'll be writing out this decimal in what it actually means, we would have that this value is going to represent 3 over 10 plus 2 here would represent 2 over 100. And 5 here is going to represent 5 over 1000. If we solve this equation, what we have is an LCM of 1000 here. And 1000 divided by 10 is 100 times 3. That's 300. 1000 divided by 100 is 10. 10 times 2 is 20. 1000 divided by 1000 is 1. 1 times 5 is 5. So we would have 325 over 1000. If we divide this 2 by 25, trying to reduce it to its lowest term, we would have 13 over 40. So essentially what we're saying is 0.325 is equal to 13 over 40. And so you can see that decimals are just another way of representing fractions. So next thing we would look at is how we can actually convert fractions into decimals. So if we take the first example, which is 3 over 4. To convert this into decimal, we'll set up our division like we would if we're trying to carry out this division normally. And so that will be 3 divided by 4. 3 divided by 4. That's not possible. That's 0. And so to make this division possible, we're going to add a 0 to the 3 here to make it 30. Now the consequence of adding this 0 is that we get a decimal point in our solution as well. And so now we can carry out our division. 4 will divide 30 7 times. And that's going to use 28. So 7 times 4 is going to be 28. Carry out that subtraction and you have 2. In order to make this division possible again, we'll add a 0 here. We don't need to add a decimal point again because we already have 1 here. So 20 divided by 4, that's going to be possible 5 times. And 5 times 4 is 20. We carry out this subtraction, we have 0. So what we're saying essentially is that 3 over 4 is equal to 0.75. And that's how you convert fractions into decimals. If we take another example, 2 over 5. Again, we set up our division like we would normally. That is 2 divided by 5. That's 2 divided by 5 is not possible. To make that possible, we had a 0 here and we'll add our decimal point. 20 divided by 5 now is possible 4 times. And 4 times 5 is 20. And that's the end of our division. So what we're saying is 2 over 5 is equal to 0.4. If we look at another example, 5 divided by 40. Now I would say we should solve this into its lowest term before we go ahead, and that will be, this can be divided by 5 to give us 1. 40 can be divided by 5 to give us 8. So we set up our division now, which is 1 divided by 8. 1 divided by 8 is not possible. That's 0. To make that possible, we add a 0 here, and don't forget to add your decimal point. Now 10 divided by 8 is possible one time, and 1 times 8 is 8. So that subtraction will give 20. Now to make this division possible, we'll add another 0 here, and 20 divided by 8 is possible 2 times. 2 times 8 is 16. That will yield 4. We add our 0 here. 40 divided by 8 is 5. 5 times 8 is 14. And this is going to be equal to 0. So we have 5 over 40, which is equal to 1 over 8 in its lowest terms, is equal to 0.125. If we have another example, which is 4 divided by 10, we can also put this in its lowest term. 4 divided by 2 is 2. 10 divided by 2 is 5. We'll set up our division like we would, which is 2 divided by 5. Now 2 divided by 5 is not possible, that's 0. To make this possible, we add a 0 here. And don't forget to add your decimal point following that. 20 divided by 5 is 4. 4 times 5 is 20. So that's 0. So 4 over 10 is equal to 0.4. Now if we stop here for a minute and look at this equation, 4 over 10 is equal to 0.4. I can tell you without trying it that 6 over 10 is equal to 0.6. And 7 over 10 is equal to 0.7. So if you have a situation where you have a number divided by 10, all you have to do is move the imaginary point in front of that number one place over the number, and you have your solution. So if we try it out without solving, if we have 3 over 10, for example, that's going to be equal to, if we write out 3, we imagine that there's a decimal point after the number here, which will make this 3.0 essentially, and we'll move our decimal place 1 point over and put it here. So this is going to be 0.3. So 4, we already tried 4. So let's say 8 over 10, for example, is going to be, you guessed it, 0.8. What if we have a situation where we have 2.3 over 10? It's the same thing. We have our 2.3. We'll move our decimal point 1 place to the left. And so this is going to be 0.23. But what if we had 2.3 divided by 100, for example? In this case, we'll move our decimal place 2 places to the left. So 1, 2. Decimal point is here. We have to fill this with a 0. So our answer is going to be 0.023. So let's keep on converting fractions. Let's try out this particular case where we have 22 over 7. And that's going to be 22 divided by 7. Now, 22 divided by 7, 7 can divide 22 3 times. 3 times 7 is 21. 22 minus 21 is equal to 1. Now, 1 divided by 7 is not possible. And to do that, to make it possible, we add 0 here. Now, the consequence of adding this 0, like we've seen in previous cases, is the decimal point here. So now 10 divided by 7 results into 1. 1 times 7 is 7. 10 minus 7 is 3. We'll add a 0 here. 30 divided by 7 7 can go into 30 4 times, and 4 times 7 is 28. 30 minus 28 is equal to 2. We had a 0 here. 7 can divide 20 2 times, and 2 times 7 is 14. 20 minus 14 is equal to 6. We had a 0 here. And 60 can be divided by 7 8 times. 8 times 7 is equal to 56. 56 minus 60 minus 56 is equal to 4. We had a 0 here. 40 can be divided by 7 5 times. 5 multiplied by 7 is 35. 40 minus 35 is 5. Now, 50 can be divided by 7 times. Yeah, 7 times 7 is 49. Since we're running out of paper, I think I'll suggest that we stop here. But my point is that this division can tend to go on forever. And so if we write down our solution as we are right now, that's 22 over 7 is equal to 3.142857, which can be continued. And this brings us to another thing in decimals, which we call approximating to decimal places, to certain number of decimal places or certain number of significant figures. So if we go here and we write down our answer as 3.142857, I think that was the last number we got here. Now, if you are asked to write this down to 3 decimal places, now what they are saying is that you count your figures from after your decimal point. 1, 2, 3. You've been asked to truncate the number here, 3.142. But there's a catch. You look at the next number. If the next number is greater than or equal to 5, then you approximate or you round up. I think that should be a better word to use. You round up the preceding number. So in this case, 8 is the next number after the third decimal place. So we can round up 2 to 3. So 3 decimal places is going to be equal to 3.143. But if you were asked to write this to 3 significant figures, what this means is that you count from the first non-zero number in the figure you're trying to round up. So 1, 2, 3, and then you look at this, you apply the same technique, which is if the next number is greater than or equal to 5, you round up the preceding number. But if it is not, you write it out as it is. So in this case, 3 significant figures is 1, 2, 3. 3.14. 2 is the next number. It's less than 5, so we write it down as it is, which is 3.14. If we try rounding up other numbers, if we have a number such as 1467.82593, for example. So imagine that you were asked to write this to 2 significant places. Or to 3 decimal places. Please feel free to pause the video and try this out. Now, if you're asked to write to 2 significant places, so we count from the first non-zero number in this figure we're rounding up, and that's 1. 1, 2. 4 is the second significant number in this figure. The next number is 6, which is greater than 5. So we can round up 4 to 5. And so our number in two significant places is going to be 1,500. We don't need to write down the decimal places, but we might as well, just to show you that all these other places become 0 after your second significant number. Now we're asked to also write down this figure in 3 decimal places. So we go to the decimal point and we count 3 places. 1, 2, 3. 5 is where we stop. So we go to the next number, which is 9, greater than 5. So we can round 5 up to 6. And so this number in 3 decimal places is going to be 1,467.826. Now I hope you understand the difference between significant places and decimal places. But let's just do one more so that we are sure we understand that if we have a number such as 30.628 and we're asked to write this down to 3 significant places, and 4 decimal places. Of course, you can also pause the video to try it out yourself, see if you get it. So 3 significant places is going to be, counting from the first non-zero number, which is 3, 1, 2, 3. So the number in 3 significant places is going to be 30.6. 2 is less than 5, so we cannot round 6 up. In 4 decimal places, it's going to be 1, counting after the decimal place, 1, 2, 3. In this case, we don't have any number here, but we have to write down the number in 4 decimal places, so we add a 0 to make up. And so our number in 4 decimal places is going to be 30.6280. I hope that's clear about significant places and decimal places. The next thing we're going to be learning is how to convert decimals back to fraction. So if we have decimals, how can we convert back to fraction? The first example we'll be looking at is 0.2. Now to convert 0.2 to fraction, we count the number of decimal places we have. In this case, just 1. And so we multiply. Here we can assume that 0.2 is over 1. And we multiply by 10 over 10. And this is going to be equal to 2 divided by 10. 0.2 times 10 is 2. And 1 times 10 is 10. And this is going to be, if we reduce this to its lowest term, 2 divided by 2 is 1, and 10 divided by 2 is 5. The number of decimal places determine the number of zeros you have after your 1 here. So if we have 0.75 as an example, we count the number of decimal places. In this case, 1, 2, that's 0.75. 2 figures, 1, 2, 2 decimal places. So we multiply by 100. 2 decimal places, we have 2 zeros. 100. And so 0.75 multiplied by 100. This time we are moving the decimal places to the right. If you multiply by 100, move it twice to the right. And that's going to be 75 over 100. If you reduce this to its lowest term, you can just divide both figures by 25. And so 75 divided by 25 is going to be 3. And 100 divided by 25 is going to be 4. So 0.75 is equal to 3 over 4. Let's solve more examples. If we have 0.325, we'll assume this is over 1. So we count the number of decimal places. 1, 2, 3. Don't forget, the number of decimal places determine the number of zeros you have after your 1. So that's 3 zeros there, 1,000. 1000. And this is going to be, we'll move our decimal places 3 places to the right, so that will result into 325 over 1000. If we reduce that to the lowest term, we would have, let's do it little by little here. So if we divide this by 25, 300 divided by 25, that's 4 times 3, that's 12 plus 1, that's 13. So 13. And if we divide 100 by 25, that's 4, so 40. So 13 over 14. If we solve another example, 0.45, please feel free to pause the video to try this out. Count the number of decimal places, which is 2 here, 1, 2, 1, 2. And that's going to be equal to 45 over 100. 45 divided by 5 is 9. 100 divided by 5 is 20. And that's the answer. So 0.45 is equal to 9 over 20. If we try one more example, 0.62. There are 2 decimal places here. So 1, 2, 1, 2, and that's going to be 62 divided by 100. If we divide that by 2, that's going to be 31, and if we divide it by 2, it's going to be 50. So in the lowest term, 0.62 is equal to 31 over 50. But what if we have repeating figures? Repeating decimals. Now let's start with an example such as 0.2828282828 keeps repeating. Now to write this in shorthand mathematical terms, we say 0.28 with a dot over the repeating figures. So if you see a notation like this in any mathematical textbook, 0.28 with dots over them, or some people also write it as 0.28 with a bar over both the numbers that are repeating. So either of this case, what it means is that 2.8 is repeating as 28, 28, 28, 28, 28, 28. In this case, we don't know exactly, we can't count the number of decimal places we have because it's continuing. So imagine that we have a situation where we know that this is 0.28 repeating. Now we can be tempted to say we multiply this by 100 over 100, and that's going to be equal to 28.28 still repeating, because you know if you multiply this by 100, what you have is you move your 2 decimal places to the right, but you still have a repeating 282828, so you have 28 points repeating 28. So if you multiply 0.28 repeating by 100, you have 28.28 repeating. So if we isolate the numerator part for an instance and forget the denominator, so we bring this down here, we have 0.28 repeating times 100 is equal to 28.28 repeating. Now what we're trying to do is convert this portion to fraction, this part to fractions. And to do that, we have to eliminate the repeating part. So what if we subtract 0.28 repeating from both sides? So in this case, we have 0.28 repeating times 100 minus 0.28 repeating equals 28.28 repeating minus 0.28 repeating. So here what we have is we have hundreds of 0.28 and we're subtracting one 0.28. So if, for example, if you have 100 x, for example, and you're subtracting x from it, what you have is 99x remaining. So if we apply the same logic here, we have 100 0.28 repeatings, and we're subtracting 1 0.28 repeating from it. So what we would have left is 99 times 0.28 repeating. We have 99 0.28 repeatings, and here we have 28.28 repeating minus 0.28 repeating, so we're left to 28 here. And so 0.28 repeating, which is what we're actually trying to convert into fractions. If we make that the subject of the formula here, which is something we're going to be learning to do later, we can send 99 over here as a division. So 99 comes here to divide 28. And so 0.28 repeating is equal to 28 over 99. So this can be a standard for us. What we know before is that when you're trying to convert a fraction, when you're trying to convert a decimal into a fraction, you count the number of places and then multiply it by 1 with zeros equal to the number of places. But in this case, what we would have is count the number of repeating figures and divide by 9 repeating to the number of decimals of the repeating figures. So in this case, we have 2 figures repeating, so we have it divided by 99. And if you punch this into your calculator, you'd actually see that it results into 0.28882. Sorry, it results into 0.28282828. So that's how you convert repeating decimals into fractions. Now, we don't have to do all this long arithmetic again, since we already know what we're looking for. So if we solve other examples, 3, 6 repeating. In this case, there are 2 figures repeating here. So we know that our fraction is going to be 36, which is the repeating figures, over 9. And we can actually reduce this into a lower term. If we divide here by 3, we would have 12, and if we divide this by 3, we have 33. But we can still divide further. 3 goes here 4 times, and 3 goes here 11 times. So 0.36 is equal to 4 over 11. If we try another example, 0.7 repeating. In this case, only one number is repeating. So we have 7, which is the repeating number, over 19. And that's your answer, because here we can't reduce any further. What if we have an example such as 4.327 repeating? Now in this case, what this means is 4 plus 0.327 repeating. So we know that this is 4 over 1. Doesn't make any difference if you divide something by 1, so that's still 4. And there are 3 decimal places repeating here. So we have 327 over 999. Now we can reduce this to a lower term. If we divide this by 3, that's 109 divided by 333. So what we have is 4109 divided by 333. And to make this an improper fraction, we can have, that will be 333 multiplied by 4 plus 107. And that's 333 multiplied by 4. That's 1332 plus 109. That's 1441 divided by 3, 3, 3. I don't think there's a way to reduce this any further than it is right now. So that's our final answer in fractions. If we do one more, .93 repeating. Now again, this is going to be equal to 2 plus 0.93 repeating. So we know that this is equal to 2 over 1 plus 93 over, there are two decimal places repeating, so we have 9, 9. We can divide this by 3 to give us 31, and we can divide this by 3 to give us 33. So we have 231 over 33. To convert this into an improper fraction, that will be 33 multiplied by 2 plus 31 to give us the numerator, and that's going to be 33 multiplied by 2 is 66. 66 plus 31 is 97. So 97 divided by 33, and that's our answer. So I hope you've been you're able to understand how to convert repeating decimals into fractions. Now all you have to do is count the number of decimal places repeating, and then divide that figure. In this case, 93 is the number of repeating figures. Whatever. Okay, what if you have a peculiar situation such as 0.21 repeating? In this case, 1 is the repeating figure, 2 is not repeating. But we know that if we look at this closely, inherent in this is, in this tenths place, there's a 1 here as well. So we might as well say that this is 0.1 repeating plus 0.1, because 0.1 repeating is 0.111111, and if you add 0.1 to it, that's going to be 0.21111, which is equal to 0.21 repeating as we have here. But 2 is not repeating, so only 1 is repeating. So if we have a situation such as this where only a part of the decimal place is repeating, what you do is separate the repeating figures from the decimal points and then convert into fractions, as we will do now. So 0.21 repeating is equal to, we know that our repeating figure is 0.1. We can subtract 0.2111 from 0.111, and what we get is 0.1, and then we can convert these into fractions independently. 0.1 repeating, one decimal place is repeating, so we know that that is going to be 1 over 9 plus 0.1. We know how to convert this to fraction now. Multiply this by 10, multiply the denominator by 10, and that's going to give you 1 over 10. So that's going to have an LCM of 90. That's 10 and 9 have an LCM of 90. 90 divided by 9 is 10. 10 times 1 is 10, plus 90 divided by 10 is 9. 9 times 1 is 9. And that's 19 over 90. Please check out my previous videos on arithmetic operations on fractions to be familiar with how to add up fractions. And so 0.21 repeating is equal to 19.9. And you can try that out in your calculator just to be sure. 19 divided by 90 is equal to 0.211111. Let's try out another example. If we have 0.523 repeating, Now you know that the repeating figure is 0.3. So 0.3, what you need to find out now is what adds up to your 0.3 repeating to give you 0.52 repeating. So subtract 0.52, 0.523 repeating 3333 minus 0.3333333, and that gives you 0.1. So that way you'll be able to separate your decimal places into the repeating numbers and the non-repeating numbers, and then you can convert into fractions independently. So the number of repeating numbers here is 1. So we know that this is going to be equal to 3/9 plus 0.19, two decimal places here. We have to multiply the numerator by 100 and the denominator by 100, and that's going to be 19/100. So we can reduce this. 3 divided by 3 gives you 1. 3 divided by 9 gives you 3. This is not reducible. So this is going to give us an LCM of 300. That's 3 and 100. And 300 divided by 3 is 100. 100 times 1 is 100. Plus 300 divided by 100 is 3. 3 times 19 is equal to 57. And this is equal to 157 divided by 300. And that's the answer to that. If we try one more, if we have 0.64 with 4 repeating, so we know that the number repeating here is 0.4, and 0.64 repeating minus 0.4 repeating, that would yield 0.2. So we convert this to fractions independently. This is one decimal point here, and that's going to be one decimal place, right? So that's going to be 4 divided by 9 plus 0.2 is going to be 2/10. And so that's going to give us a decimal place of 90. 90 divided by 9 is 10. 10 times 4 is 40. Plus 90 divided by 10 is 9. 9 times 2 is 18. And that's 58/90. If you divide this by 2, you have 25 plus 4, that's 29. And 2 divided by 90 is 45. That's lowest time. So 0.64 repeating is 29.4. Thank you.